Good morning to all. Welcome to the presentation on topic the common collector amplifier. So we all know that two terminals are needed for the input and two terminals are needed for the output of a current, but the transistors have only three terminals. So one terminal have to be taken as common terminal for both input and output. As the name suggests, the common collector configuration has the collector terminal as the common terminal. The input of this configuration is between the base and collector terminal, and the output is between the emitter and collector terminal. It is also called emitter follower or voltage follower. It is called so because the output emitter voltage always follows the input base voltage. For example, let us take the emitter voltage as 0.7 voltage, and if the input is 5 volt, then the output is 4.3 volt. The output voltage is always near the input voltage. This configuration is widely used as buffer, and it is also called as a voltage buffer. So the next slide shows the two configurational setup of NPN and PNP configuration. The input is applied between the base and the collector terminals, as I have already said. The input current is denoted by IB and the input voltage is denoted by VB. The collector terminal is grounded in this configuration. The output current is the emitter current and is denoted by IE, and the output voltage is denoted by VCE. The output emitter current is the sum of input base and the collector current. The emitter junction is forward biased and the collector junction is reverse biased in this configuration. The common collector configuration have high input impedance and low output impedance. It has low voltage gain, high current gain, and the power gain of this configuration is medium. This configuration is mostly used for impedance matching. That is, the high impedance source is used to drive low impedance load. It means that the output of a circuit is very high, output impedance of the circuit is very high, and the input impedance of the another circuit is very low. These both cannot be connected because the loading occurs and the efficiency of transfer of the current is very poor because of these variation in impedance. For this, the voltage follower is used, and it has high input impedance and low output impedance, which matches the high output impedance of the circuit and low input impedance of the other circuit which this voltage follower is connected to. So, the input characteristics of common collector configuration. The input characteristics are the relationship between the input current and the input voltage, keeping the output voltage constant. Here, input current is IB and the input voltage is VBE and the output voltage is VCE. The output voltage VCE initially kept at 3V and kept constant. The input voltage VBE is increased from 0 gradually, and the corresponding input current IB is noted. Then the output voltage is increased to 5 volt and kept constant. So the output voltage is gradually increased and the input current is again noted. So the output characteristics of common collector configuration. It is the relationship between the output current and the output voltage, keeping the input current constant. So initially the input current IB is kept at 0 and kept constant. Slowly the input current IB is increased like 10 microampere or 20 microampere and kept constant at that value. And the output voltage is increased gradually from 0 and the corresponding output current IE is noted. When the input current is 0, no current flows in the transistor and it is called cutoff region. When the input current is very high and the current through the transistor is also high, the transistor will be in a saturation region. The region where there is a change in output current for the change in output voltage is called the active region. So these three are the main regions where the transistor works. There is another region, breakdown region, where the transistor won't work. So next, let's talk about the input impedance. The input impedance for the common collector circuit analysis is determined by the following equation. The base impedance is the input impedance of the common collector circuit. It is given by the equation number 6.23. The equation is similar to the equation of transistor impedance in a common emitter circuit with unbypassed emitter resistance, except that the load resistance is now parallel with emitter resistance. The circuit impedance is also given by the parallel connection of emitter resistance, load resistance, and the base impedance. The input impedance at the transistor base in a common collector circuit can be quickly estimated. Let's say that a circuit with emitter resistance of 1 kilo ohm and the H parameter of is 100. It has a base impedance approximately equals to 100 kilo ohm if and only the load resistance is very much greater than emitter resistance. So now let's talk about the output impedance. The AC voltage at the output of a CC circuit is all feedback to the input. This fact is used in determining the output impedance. The output impedance of a common collector is the impedance at its emitter terminal. The signal voltage is assumed to be 0 and it is used to calculate the emitter current. With the signal voltage 0, the base current is produced by the feedback voltage, and this is the equation for to calculate the emitter impedance. So note that the output impedance at the emitter terminal is given by these equations. The equation gives the device output impedance. The circuit output impedance also involves emitter resistance. Emitter resistance is usually larger than the emitter impedance, so that the output impedance is approximately equal to emitter impedance. So next, talk about the voltage gain. The AC output voltage from a CC circuit is almost exactly equal to the input voltage. The precise equation for voltage gain is easily derived by considering the AC output and input voltages. This is the equation for calculating the voltage gain. Because of the internal resistance at the base emitter junction is approximately equals to H parameter of base collector. This equation can be used in situations where the device parameters are unknown. Usually the emitter resistance and load resistance is parallel, so it is much larger than the H parameter, and the CC circuit voltage gain is simply taken as approximately 1. So let's combine everything together, and the summary of common collector circuit performance is that a common collector circuit analysis has a voltage gain of 1. It has no phase shift between input and output. It has a high input impedance and a low output impedance. Because of this high input impedance and low output impedance and unity gain means its voltage gain is 1. The common collector circuit is normally used as buffer amplifier. It is placed between high impedance signal source and a low impedance load. So this is the summary, and that's all. Thank you.